Hello everyone, my name is Maria Stefania Calvillo, and this is not a party. This is going to be a presentation about balloon geometry. This is interactive advanced concept presentation 7 for General Chemistry 1 for Duane University, and as I mentioned, today's experiment is called balloon geometry. So today we're going to be explaining all the different electron domain geometries. Many familiar chemical and biochemical process depends heavily on three-dimensional shapes of molecules and or ions involved. Our sense of smell is one example. The effectiveness of a particular drug could be another example. Although the shape of a molecule or polyatomic ion must be determined experimentally, we can predict their shapes reasonably while using Lewis structures. And the balanced shell electron pair repulsion, or BSEPR model. With this experiment, we'll show the shapes of molecules of the general type of ABX, where A is a central atom surrounded by X B atoms, and X can have an integer value of 2 up to 6. An electrodomain is a lone pair or bond regardless of whether the bond is single, double, or triple. So in this activity, each balloon represents an electrodomain surrounding an atom. When connected, balloons naturally adopt the lowest energy arrangement predicted by the BSEPR model. So for today's experiment, we're only going to need balloons. So let's start. I already inflated some of the balloons. I'm just going to show you how to do the first one, and we'll arrange the rest. So first, the type of molecule will be AB2, and the electron domain geometry will be trigonal planar, yes. Okay, so first we are going to inflate these 3 balloons. Okay, tie the balloons. Very good. One more. This will represent, as I mentioned, the trigonal planar. Okay, we're going to tie them together. I'll do this 2 first. So here we have the trigonal planar. Each balloon represents an electron domain and surrounding an atom So the total of electron domains is 3. The number of lone pairs will be 1. An example of this will be sulfur dioxide, or SO2. Okay, let's move to the next one. We won't use this one later, so I'll just put it away over here. So for the next one, it's called tetrahedral. So we'll need 4 balloons. I already have it here. This is an example of tetrahedral. Number of lone pairs is 1, and an example of this one is NH3, or ammonia. Okay, so as I mentioned, each balloon represents an electron domain. Let's move to the next one. AB2, also tetrahedral. Number of lone pairs is 2, and very common example of this is water, or H2O. Okay, let's move to the next one. For the next one, we'll be using 5 balloons. So we're done with this one for now. So I already have 3 here and a pair of balloons here. So I'm just going to try to tie them. Okay, so the type of molecule in this example is AB4. It has total number of 5 electrodomains. That's why we have 5 balloons. And number of lone pairs is 1. An example of this is sulfur tetrafluoride, or SF4. Okay, we'll use this one for the next example, which is AB3. Same total number of electrons is 5. Number of lone pairs in this case is 2. And an example of this is chlorine trifluoride, or ClF3. Okay, so let's move to the next one. The next one will be same trigonal bipyramidal. I forgot to mention that earlier. When it has like the 5 electron domains, the electron domain geometry is trigonal bipyramidal. So for the next one, it's AB2 trigonal bipyramidal. Number of lone pairs is 3. An example of this will be iodine monofluoride, or IF2. Okay, so all done with this one. And for the next one, we'll be using 6 balloons. I already have them here. I'm just going to tie them first. Okay, I already have a pair. Two more. Okay, we're going to tie them together. Here. So for this example, or for this electrode domain, the total number is 6, and it's called octahedral. The type of molecule is AB5. Number of lone pairs is 1, and an example of this is bromine pentafluorine, or BrF5. Okay, and for the last one, we're also be using this 6 balloons. The total number of electron domains is 6. The type of molecule is AB4. Number of lone pairs, this is also called octahedral. Number of lone pairs is 2. An example of this is xenon tetrafluoride, or XeF4. So this is all for today. Just a recap, we saw like the type of molecules, the electron domain geometry. Mainly the mainly thing in this experiment was to show you the electron domain geometry. So let's recap real quick. So the first one was trigonal planar, which I had 3 balloons. I have 3 balloons here. tetrahedral, total number of electrons is 4. The trigonal bipyramidal, it's this one, the 5 balloons. And the octahedral electrodomain geometry is with 6 balloons here, which as I already mentioned a couple of times, each balloon represents an electron domain. So this is all for today. Hope you enjoyed this video. Thank you for watching. Bye.